Hey there, science enthusiasts! Welcome back to Rat Does Science. Today, we're diving into the fascinating world of scientific inquiry. Ever wondered how scientists really know stuff? Well, stick around and I'll break it all down for you. First things first, let's talk about asking the right questions. In science, not all questions are created equal. We have investigable questions which are specific and testable through experiments or observations. A great example is, how does temperature affect plant growth? You can measure plant growth at different temperatures to find your answer. On the flip side, we have non-investigable questions. These are often too broad, opinion-based, or lack measurable variables. For instance, why are roses the best flowers? Is a lovely question, but it's subjective and can't be tested scientifically. Moving on, how do scientists verify and refine their knowledge? It's a rigorous process involving hypothesis testing, peer review, and repetition. Take Pasteur's germ theory, for example. His experiments on sterilization were tested and confirmed by other scientists, leading to groundbreaking advances in medicine and hygiene. Now, with so much information online, how do we know what's reliable? Here are some criteria to evaluate online content: source credibility, author expertise, evidence-based claims, bias, and reproducibility. For example, a research article from NASA on climate change is way more reliable than an opinion blog without scientific backing. Let's talk about identifying testable claims for investigation. A testable claim is one that can be examined through scientific investigation. For example, drinking caffeine increases reaction speed. This can be tested by measuring reaction times. However, a claim like aliens visit Earth regularly isn't testable because there's no clear way to measure or observe it scientifically. Once you've conducted an investigation, it's time to analyze the data and form conclusions. Here's how. Examine patterns in the data, compare results to the hypothesis, and use logical reasoning to explain the findings. For instance, if an experiment shows that plants exposed to more sunlight grow taller, the evidence supports the claim that sunlight impacts growth. Finally, let's touch on writing a scientific argument based on evidence. A strong scientific argument includes a clear claim, supporting data, logical reasoning, and consideration of counterarguments and limitations. For example, in a study on exercise and heart rate, a strong argument would be, regular exercise lowers resting heart rate, as shown by a study of 100 participants where heart rates decreased by 10% after 8 weeks of training. To wrap it all up, scientific inquiry involves asking investigable questions, verifying knowledge through hypothesis testing and peer review, evaluating information for reliability, designing testable claims, analyzing data logically, and constructing evidence-based arguments. By applying these principles, we can think critically about the world and separate fact from misinformation. Thanks for watching, and don't forget to like, subscribe, and hit that notification bell to stay updated with more exciting science videos. Until next time, keep questioning the world scientifically. End scene.